Welcome to the channel of Wiskunne English. In this video we're going to talk about partial derivatives. For example, now if you want to take the partial derivative to x, for example, how do you do that? Well, let's take a function of one variable. I think everyone can take derivative of this example, is 5. Because the derivative of x is 1, 1 multiplied with 5 is 5, and this is a constant. Derivative of constant is 0. It's the same for this one. So x is the variable, y and z are constant. If you take the partial derivative to x, first partial derivative, f x, so you get y to the power of 2. Y to the power of 2 is 5 in this example. And this disappears because it's a constant, and derivative of a constant is 0. If you take fy, the second derivative, or the second partial derivative, so now is y the variable, so we get example of one variable, it is 5 multiplied with x to the power of 2 plus 3. So you get 2 multiplied with 5 multiplied with x. So here we get 2 multiplied with x multiplied with y. And this is a constant, and the derivative of constant is 0. So you see 2, 2, 5 is here x, x is here the y. And the last one, third partial derivative. This is a constant. Constant is 0, so it's only z, and we get 2z. Okay. Now we're going to make a second example, and let's suppose f is a function of another function. Let's say xy multiplied g, and g is a function from r squared to r squared, like this. Okay? Let's suppose g is a very simple function, so we can take the derivative, we can differentiate it and no problem. Okay, let's take the first derivative, so first partial derivative of f, so x. Now we see, we have an x here and an x there, so we need to use the product formula. We get f multiplied with g, derivative of f multiplied with g is derivative of f multiplied with g plus derivative of g multiplied with f. So first f is in our example xy, g is in our example the function g with xz and yz. So we get y multiplied with g, and then we see there's only an x in the first part of g, so we need to take the first partial derivative. So we get plus d1, first partial derivative of g xz yz. Chain rule, because here we need to take derivative of xz, and we x is our variable, so multiplied with z and multiplied with xy, because xy is a f. Z to the power of 2 disappears because this is a constant. Now for y, second partial derivative, same principle, we have the product formula, because we have here a y and here is also y. So we get x multiplied with g x z yz plus xy multiplied with second partial derivative of g, because in the first one there is no y, d2 g x z yz multiplied with chain rule yz, derivative of yz, so it is z. Okay. Last partial derivative is 2z. So we have here a constant, but here we have 2 times z. So we need to take the first partial derivative of g and the second partial derivative of g. So we get xy multiplied with t1 g xz yz. Chain rule, z is a variable, so multiplied with x plus d2 g xz yz. Z is the variable, so multiplied with y, chain rule. Plus the derivative of z to the power of 2 is 2 times z. Okay, so this is an example of a function that consists of another function. Now, in the third example, we're going to investigate if a function is partial differentiable. For example, we have the function xy, and the function is x to the power of 2 minus y to the power of 2 divided by x to the power of 2 plus y divided to the power of 2 if x and y are not equal to 0, and if x and y are equal to 0, it's 1. The formula to investigate if you can take the derivative of function is very similar to one variable. So remember, one variable, you can see the video of derivative of a function goes like this. Now, suppose we want to investigate if the first partial derivative, so the derivative to x, exists. Then the formula becomes so now a and b are 0, so you get h0, get 0, 0. So now we are investigating if the first partial derivative for x and y equal to 0 exists. So now fh0, h can be positive or negative, but it has a value, so it will be here, and f of 0, 0 will be here. So you get h to the power of 2 divided by h to the power of 2 minus 1 divided by h. So you get 1 h to the power of 2 divided by h to the power is 1. 1 minus 1 divided by h. So the first partial derivative exists and it's equal to 0. Now we are going to see if the second partial derivative exists in 0, 0. So now it changes a little bit. Instead of y h0, it's now 0h. All the rest stays the same. So we are still here. So we get now minus h to the power 2 divided by h to the power of 2 minus 1 divided by h, in the limit of h going to 0. Now we get minus 1. Minus 1 is minus 2 divided by h, so we get plus or minus infinity. So the second partial derivative in 0, 0 does not exist. The first partial derivative exists and is 0. The second partial derivative doesn't exist. So we see the formula for one variable is very similar to the formula for two variables. Well, this was the video for partial derivative. I hope you enjoyed it, and please like the video and subscribe.